next talk is from a good friend of mine, Siddharth. He's from Genpact. He was previously with CDK Global, and is one of the senior data engineering managers. Right, he's been dealing with data for a good amount of time. So over to Siddharth.
Yeah, hi Hari. Thank you. So my name is Siddharth. I have been in the IT industry for the last 17 years, working on various data engineering projects for companies like Cognizant, ADP, CDK, and now in Genpact. So thank you. Thank you to the team here for doing all the excellent work of calling all the people and having this meetup. This looks really good. Sorry.
That's definitely one of the excellent works we are doing.
Yeah, which one?
That's one of the excellent works we are doing.
Yes, yes. Thank you, thank you. So my talk today is about how to model and explore graph data with Postgres, bit different from the previous excellent talk by Karthik. Thank you, Karthik, for that. So I will talk about 5 different topics here. I will talk about from data engineering background, why is that I'm interested in graph data with Postgres, because this is not really related to the work I do. Then I will have some recap of what is graph data. I'll take 2 use cases on how to model graph data in Postgres and a real life use case from a company, right? My job involves in dealing with a lot of data, like ingesting data from various source systems, putting that into data lake, and then building a lot of reporting views on top of that. So typically, I work with MPP databases like Redshift, BigQuery, and Snowflake. So in the last 2-3 years, I've been working with Snowflake. So why Postgres, right? So it happens that one of the problems that I deal with is called MDM, or Master Data Management. Typically, how it happens is there is an MDM hub in the company. Master data means customer data, product data, vendor data, employee data. So typically, we have an MDM hub in the company. And the MDM hub is typically a OLTP database. So MDM hub gets data from various sources of customers. So talk, for example, customer. It gets data from various sources like for customer. It becomes the hub and it feeds the data into all the downstream applications. So how we model this MDM schema and the MDM data becomes really critical. Here is one example of product, right? So it is typically how it happens is a typical tables and columns scenario. So you have product groups have got products have components, and components have subcomponents. Right, so this is easy to do, but sometimes what happens is we also have often many scenarios, like product groups can have components, products can have some components. So this becomes a graph problem. Okay, so to solve that, typically someone will recommend that why don't you go for a graph database like Neo4j, Neptune, or something like that. But again, one more new technology to learn. Already there is so many things to deal with. Why again learn one more thing? Why can't we use something that we are familiar with? So right. So can Postgres be used for this? I have personally used this on a medium-sized database. So don't talk about Facebook or LinkedIn kind of problem for a typical enterprise, medium-sized enterprise that I've worked for. This works, I can tell you. So how does it work? Right, hope I made myself, the motivation clear, right? So we have graphs everywhere, and how do we do that with Postgres, for example? What is a graph, right? Just to give a recap of the concepts here. A graph is a collection of nodes and edges. So nodes are nothing but nodes or vertices, and edges are relationships. Nodes are like entities, right? And the 2 nodes are connected by edges, right? So edges can be directed or undirected. See example here, we have got 4 nodes here, N1, N2, N8, N6. So between the edge between N1 and N2 is directed. The direction is from N1 to N2, but there is no direction between N2 and N8. So that is something like similar to bidirectional, like what you have with N2 and N6, right? Who is a graph? People here, we form a graph. We are nodes. So I know Hari knows few people, they know few people. So the relationships from the edges, we are all nodes, right? Or think of a city. You have got different places and there are roads, right? Going between different places. Some roads will be bidirectional, some roads will be only unidirectional. See in Facebook, see in LinkedIn, right? LinkedIn, if I am suppose he's a big star and people are following him, then that is a unidirectional. But if we are friends, then there's a bidirectional edge, right? So they're everywhere. So there's a graph, but how do we deal with that? So we'll come to the crux of the model. We have graph. How do we model it in a relational database and specific with Postgres? I give a small example. I'll go through it slowly because I know this can be a little difficult to catch in the beginning. So I'll go through a bit slowly for everyone. We have got 6 friends here, right? John, Jack, Jill, Jerry, Jobs, and Jeff. There are 6 people. So so how do we present it? You create a nodes table in Postgres, right? In Postgres, create table nodes where you have 3 columns or many columns. One is the node ID, node name, and all the node attributes. You can have many other columns for the node. Node ID can be an integer or a serial column, node name, and node data. Give an example here. After creating that table, you will insert into nodes and you will have values, right? For the sake of simplicity, I have not defined that node ID as a serial column. So you have node ID, node name, and node data. Fair enough? Then you have, I'll just go through it step by step. I'll show a directed graph here, not the undirected graph. So think of it as a one-way friendship. So Jack is a friend of John, but John is not a friend of Jack. So the edge between John and Jack is directed, right? So, and then you have this graph here. It's looking like a tree, but like tree is a graph, but every graph is not a tree. So this is the situation you have here with all the edges. How do we present this in the database? You create one edge table. Create table edges. You'll have 2 columns, like previous node and next node. Previous node, next node. Right? Previous node is an integer which references the node ID in the nodes table. Next node is a integer which references node ID in the nodes table. And the combination of that is a composite key, the primary key for the table. So you insert the relationship here. You have 1 and 2, right? 1 and 2 are, there is an edge. So you insert 1 and 2. 1 is the previous node, 2 is the next node. Same thing for 4, 2, 2, 3, 5, 3, and 3, 6. Goes from 3 to 6. So let me run this in the database. So I have my nodes table, right? So I created the nodes table. After that I created the edges table. I'll insert a bunch of nodes into the nodes table. I'll create the node relationship in the edges table. Fair enough? Now the question is, I'll go back to this. Show me all the friends of John. Show me John's friends of friends. Right? In the naive way, how will you write it? You will write a bunch of joins. Edge again join that edge to edge and then software page, right? So it becomes really messy, as you can see here. Right? So just to find that John's friend are Jack, Jill, and then Jeff. You have to write that you have to, so there is no end to it. You cannot create just analysis of that edges table and keep going. It's not going to go anywhere. This is where a relatively less used functionality in the relational database called recursive cities, right? That is what comes into picture. I am sure some of you are familiar with it, but some of you might not be. So I will take an example here on how you will use the recursive CTE to use the nodes table and the edges table and get this data. So recursive CTE, you write, start with recursive and the name of the CTE. So let's say call it CTE friends. Is so recursive CTE has got two parts. One is called the base query and one is called the recursive query. Let me give an example. What do I want here? I want John's friends of friends. I want to write a query whose outputs would be Jack, Jill and Jeff. Fair enough? So I want a output I want a query whose output will be 2, 3 and 6, Jack, Jill and Jeff. So John and Jack, that happens to be the base query. So I want to write the base query like this. Select, to come to this, from edges E, where previous node equals 1 and E dot next node. This becomes my base query. So this gives me 2. So now I got 2. So what happens is, in the recursive CTE, the base query becomes a temporary table and that table gets iteratively joined to the main table so that you can get all the other values, right? So you have to join this value to the whole table now. So you can use union or union all. I'll come to the difference of that. So let me use union all here. Select. So think of this. This is a temporary table. The table is called CTE friends and has one value, has one column next node. So I will write select from CTE friends F join edges E on F dot next node equals E dot previous node and select for me E dot next node. So I think I got my recursive query set. Oh, sorry. So I got 2, 3, 6, that's what I was looking for. You can now join this one to the nodes and get all the values. So what is the point is, by using recursive CTEs, you can model graph data in the Postgres or any relational database like Postgres. We'll talk about why Postgres is special here, but it is very much possible, right? So, just because the recursive queries were really difficult for my team when we started modeling this, so we had to go through the manual and do some examples. But you can just think of it as how you will run, how will you sum the numbers from 1 to 5. You can use recursion here. You can use recursion here to get factorial, which is the classic example. You can find John's friends of friends. Whose friends of friends is Jill? Similar way, you have to write the base query correctly, which will directly go to that example, which will be executed only once. So base query is executed only once, and that result set a temporary table that gets used with your environment, and then that is what creates your recursive results. Right? So to understand what recursion is, you have to first understand recursion. It is always tricky. So this is a typical case, right? What happens when you have bidirectional friendship? I'll come to that. We have also used this technique, right, to model tasks in a project. So let's say you have a company which is going to install some products in the customer locations. So the installation process has a bunch of tasks that have to be done one after the other, right? So the tasks become the nodes, and that the related assembly graph, that becomes your graph data structure, right? So in this case, you have got multiple tasks. So those tasks come one after another. So T9 gives to T2, T2 gives to T6. So this can also be a graph problem. You can ask one question, right? So you can model this. So I'm not going to show the example of a node here, but the task edges is very simple here. Similar way, you create the task edges, you insert the relationships at edges into the task edges table. Right? So then you can again write a recursive query here. So to find out all the tasks to complete before T7, for example. So this is my task edges table. Yeah, insert into task edges values. So same as here, 9 to 2, 2 to 6, 6 to 7. So I have it. I am going to insert this here. Recursive task list. This is my base query. Look at this base query. So the base query is that I want to find out all the tasks that are coming before 7. Right? Basically all of these. So the base query will be, the results will be T6. That is what coming before T7. So you can write select from task edges where the next node is 7. And then show me the previous node. Basically the result of this should be 6. This is very critical. So getting the base case correct is very critical. That can be tricky. But once you get that, joining that result set, keep that as a temporary table, join that to the rest of the tables becomes quite easy, right? So then you do union all and join this. Basically you are referring to that same query inside the query itself, right? The CTE name. So join that task list to the task edges on the next node equal to previous node step from task list. This gives you everything, right? All of this. But then this is not ordered, right? There is no ordering of this. I want to get all the tasks that are coming before T7, but in a proper order. So if you start with T9 and T4, T8, then T2, T5, and T6. So you have to introduce a depth here, right? So see this query here, where you can start with the depth and then you can implement the depth. So your base query becomes this starts with 6 and 1, and then this is the recursive query. When you run this, you basically get 1, 2, 3. So you can see here that 6 is the last task, 6 is the last one before T7, 2, 5 come before that in the depth level 2, and 9, 4, 8 come in the level 3, in the depth 3. Very tricky. So what I found is that almost everything you want to do by to analyze all this data is all possible. Creating one more challenge here. I'm going to add a multi-path here. So you also have an edge coming from 5 to 2, right? So let me introduce that. I'm going to insert into task edges values 5, 2. This is where things get tricky. The union all won't work here. You get lots of duplicates. So if you see here, this is going to give, this is not going to end, right? This is going to go on and on. Actually, I will stop it. Yeah. It goes into infinite loop. So this is where you have to go for union to make it unique. Now you're fine. Right? So the union will make sure that the register set that you get doesn't have any duplicates. Postgres 14 has a lot of features to find out cycles in the graph. That was not there before. So if I add 2 more edges from P8 to P9 and P2 to P8, you can see there is a cycle here, right? So previously it used to write lots of rules inside the query to find out the cycles. But what I have seen is that we have some features now in Postgres 14. So this just goes on and on. This will not end. This is infinite loop. So you will be able to detect the loop. Look at this. This is the thing. What I am seeing is cycle previous on the previous node set this cycle using path. So cycle detection is very easy just by adding this to your CTE. Is a qualifier, and it also gives the path that is being taken by the graph to come to what you are looking for. What we have found is this is really good. Okay. But any questions so far? So I just want to know if so anybody of you have used Postgres or any JSON databases to store and query graph data? Any experience? You have done that? How was the experience? Is all okay?
Yeah, I didn't like it much personally. I've got so many different alternatives.
Right.
This is my personal opinion.
Yeah. There is true. This is can be a bit tricky if you want to write this query, but we just I mean what I have seen is that for our use case, we just don't want to go for one move.
Thousands of them. One is blocking each other. So it's like a relationship. He is blocking. So I need to find out the root who is blocking anyone. So this is connected.
Can be quite useful.
Don't we have any extension that supports that?
That is there. I saw that there were a lot of extensions, but I have not used any of those. I found, I did some research. There's a company, one delivery company called Ingrid. It's like our delivery, they do shipping, right? So they have a lot of customers and shippers. So they are using Postgres to model their graph data, and they are happy with it. So they are saying they have 5 inserts into each nodes and per second. So 5 inserts per second to nodes and edges, and 2 reads per second. They're saying 99% of the search queries come in less than 10 milliseconds. Performance is reasonably good. I saw their CTO there said they will get solutions for graph data, but they thought this is going to overkill, and then it became like one more thing to learn about. So they've gone for Postgres. They are happy with the solution because they implement it quickly and stable and doesn't consume a lot of resources. So yeah, so people are using this. I can tell you that this is good. This is okay. One advantage I have seen is that with Postgres, you can go for this as a hub. Again, it is MDM hub. It is MDM hub. So you can store all kinds of data types also, right? If you have blobs or if you have JSON values, you can store that, right? So that makes it much easier. And what's with the high-level model of that you have, your data model, it works pretty nicely. What we have done is, obviously, we cannot expect our business users to write those complicated queries. So we have taken the most used subgraphs that they are interested in. Like I said, who are the people who are friends and friends of John? That becomes a requirement that we get from business users. We either create views or materialized views, and we use that. We give that to our users so that they can use tools like reporting tools to read off that. Is working well. Postgres 14 in particular has done a lot of work to introduce graph queries. So simplified cycle detection, finding shortest paths, removing multi-paths, and including your breadth first search, depth first search, all of those things can be done easily by just adding some qualifiers to that CT. I found that it's quite amazing. I also read, I know there are some extensions I saw about that. I haven't experimented with that personally, so I'm not able to comment on that. If anybody has done that, please talk about it. I saw that there is also in the roadmap, there is some support going to come for graph query language or GQL. So they might, so I know SQL is going places. So before 2010-12, they came up with NoSQL. So SQL is going to be killed. But at this point, my life is all about SQL only. That's what we do. So SQL has not gone anywhere. So to all the people who join my team, I always say that just learn SQL, you will survive for a long, long time. Without that, you are going to be in trouble. So SQL, so every company is now supporting, including Spark also, they come up with Spark SQL. I said, okay, at least you don't come up with SQL, at least something, right? Everybody knows SQL. So, but I think SQL is going to have more features to support graph. So somewhere that Alibaba Cloud published a Postgres graph benchmark with 12,000 transactions per second and 2.1 millisecond per query with 5 billion nodes. So they are actually doing it at a very large web scale kind of computing and finding that Postgres can support graph reasonably well. In fact, somewhere in EDB, the enterprise, what is it? The Postgres vendor, right? EDB. So they're telling that Postgres is beating Neo4j Community Edition on the graph data. So that is getting really good feedback there. Yeah. So yeah, two-way friendship also you can do. It becomes a little bit complicated because you have to write little bit more qualifiers to do that, but you can definitely try that. Quite a few references on this. Actually, if you search, and when I was searching for this presentation, I wanted to find some material on this. I found that they have a lot of, especially this Postgres. So you see this Postgres, this with queries common table expression. I saw that was really, really well explained. All these features like the breadth first search, depth first search, how to detect cycles, how to detect paths, how to store the paths. The examples are really good. And I would, so any of you who are interested in trying this could definitely go through this. Yeah, that's it I had from my end. But I can tell you, we are happy with it. Because we don't have to go to many things. The thing is, as a manager, the main point is not about just trying new stuff. Because they're just technology, as you see, there's just too many new things coming up. It's very difficult to keep pace with everything new. We have to have some anchor, some foundation that you can build some expertise. So we want to make things more maintainable. That becomes really important. I see that in my experience, when I try to make my team do something interesting, people just want to try something new. Something new is there, some new open source libraries, they just want to try that. We have to be more kind of think of future and make things more maintainable. And having Postgres as a solution which can do obviously your relational database stuff plus also the document database, because it can also be used as a document database, can be used as a data warehouse. Obviously all these things, be it the Redshift, be it Snowflake, they're all offshoots of Greenplum, they're all from Postgres. And now this also, graph data can also be stored in that. I think this is really amazing. I think this technology is going to go places, and this is a really good thing to learn. I'm very happy about Postgres. Yeah, but any questions for me as such? No, nothing. For our use case, yes, it works. There's yeah. Yeah, so there's one guy named Michael Stonebreaker. So he is the database guru. He is the one who came up with this Ingress technology, which later became Postgres. So, and he has lots of videos on internet, on YouTube. I think MIT guy, right? Almost 75 or so now. But still he talks so much interesting stuff. Really good guy, right? So he talks about something called, if you take one very specific use case and you want to optimize really for millisecond, microsecond up to that, right? You can always do that. But right? So if you want to optimize only for graph data, Neo4j can do a lot of wonderful stuff. But we were talking about some general purpose solution which can meet graph plus all the other stuff as well. You want to expose some APIs from that, very easy, right? right? So building a general purpose solution which can meet the needs of many use cases is always difficult. Currently, Snowflake is coming up with an H-step solution. It's called hybrid transactional processing, right? So they have been typically OLAP-based solution where you run trillions of records and you want to summarize those, aggregate those. But now they also, because it's not possible to have different ODS and different data warehouse, you want to have all of them at the same place. So that's where they're coming up with also support for the OLTP solution. That becomes very tricky, right? You want to support both the things in the same time, becomes very tricky. So yeah. So I think that way, this is really good solution. Is it a general purpose solution? This is really good. Some extent up to some graph. That's what I have found so far for our use cases, unless it is very like your scale is web scale. We're talking about Google or Facebook kind of problem. Not many companies have that kind of problem, right? This works fine. 1 DB is enough. No. 1 DB is, one database is enough. Yeah, 100. That's what they're saying. Just go with Postgres. Don't worry about. If you go to some LinkedIn, they will say this big one. If you have this, then go there. Go there. This is there, then go here. Boss, this is just one of the problem. I also have other things to deal with. I cannot have, my whole life is only about database. I don't think other things. Just tell me one thing, boss. Okay, go with database, the Postgres. It'll happy. Just go ahead. No performance issue. You have to, performance issue is not always with database. How you model your table also matters a lot. I've always seen that when people get poor performance, they will always blame the database. But frankly, that is not the problem. Problem also happens how you model your problem, how you decompose it and make it into smaller chunks, and then do the modeling. That also matters a lot. You just cannot blame saying that I'm going to tune the query and bring it from 2.1 millisecond to 2.0 millisecond. That is not the thinking that we should always go for, right? We should also think about, are we solving the problem in the right way?
So that one question or a thought that I have is, you would have seen a lot of use cases where Postgres plus database, Postgres plus graph data is being used, right? Can you talk about any one of those use cases? I don't know, let's stitch a problem. What was the analysis behind? I don't know, how did you grab Postgres as the relational database in your current job, current projects?
Right. You mean to say how I solve different use cases, right?
Yeah.
What I have seen is Postgres is obviously very nice because there is a lot of good support, but any relational database like your Oracle, SQL Server, all that will work. What I have seen is that both OLTP and OLAP, what I have seen is I recommend that you can bring it to the same platform. The main good thing that I have seen that in my thing is, what I propose is, when you copy data multiple times, the value goes down. Say I give you a dollar bill, and you copy that file, and you create a photocopy of that, the value goes down. Okay, so copying. So my solution is try to build an architecture in such a way that you don't have to copy the data multiple times. Let's say you come up with a different Neo4j graph database which will do your MDM. But that will not be able to solve all of your use cases because product is okay. But product as such cannot solve any problem. Product also has to be joined to contract, has to be joined to billing, has to join to opportunity leads, all of these different data sets. So having all the stuff together in one physical location, in my opinion, works very well. So what I have seen is that if you create a Neo4j, then it will not solve all of your problems. You have to replicate the data and then bring it to, again, one more ODS solution. Again, you have to replicate the data and bring it into one more Snowflake. So what I often say is that I think the future is going towards that. Right? Future is going towards that where one solution will be meeting the needs of many use cases. And that's where both, you are storing the large video files is also possible. You just store the video files in, right? So you will definitely see the trend towards that, where one data platform is going to meet the needs of many use cases. It's not possible, just practically possible to have different polyglot persistence, they call that, right? It's good in theory, but in practice, in production, becomes very difficult to operationalize and manage. That's what I've seen. I really haven't come with. I'm not an specialized in this area, but I felt that this is a good use case for reasonably complex scenarios. This can be used. So as soon as we see the graph, okay, no, this is not the solution. You are using the wrong solution here. Let's go for the graph database. This need not be the first step. Try with this. If it doesn't work out for your scenario, then we will think of the other database. Just that because it is there, so we have to use it. It's not like that. So it has to be more use case driven. Again, talking from a manager's point of view, I'm more a manager than a developer, right? So people go for resume-driven development. I want to see if I write Postgres in my resume, it does not look shiny. But if I write Neo4j, it is always like, so people want to try different things in the real job which will look good on the resume. Unfortunately, that is not always what will look good. So I think that like having that sort of thinking where we want to be more pragmatic of the technology choices is really good. Just yesterday I was seeing somebody microservices and somebody was just scolding that this is not going to work like. So yeah.
While we are on this, because we have both on the blueprint are there any databases that they
Neptune. Overkill, yeah, overkill. Okay, yeah.
So those things like the nodes, the edges, and all of that. So it is also about the visualization. So graph is not about data, but also visualization. Because people can understand better and visualize better when they see those things.
That is very good actually, yeah. I mean that extensibility is really good in Postgres.
Those are the things actually. So when we say graph database, it's also about visualization. So that really adds to the solution of the
Yes.
I mean, here I think Postgres you are using as nothing as such different. You are trying to Postgres is offering because you are trying to
It's good. You don't want to. You don't know.
your data modeling, you are using the speed queries. Those are anyway available.
Any available there.
So
Yeah.
these smart to make Postgres do that.
Yeah. Or maybe laziness to learn something new.
You have something called Cosmos DB. Cosmos DB is a service that is provided. Someone can correct me, I think something called MongoDB Atlas is also a similar kind of product. Okay. So you have Cosmos DB actually.
All of us need to go and just market what that was it. There was one part of the world which says purpose built. If you have a use case, you have a database. If you have a use case, you have a database. This kind of marketing, but yeah,
Basics always better. Fundamentals, I think, are most important in any kind of engineering practice. Right? Lots of problems can be solved with just basic.
Right. Thank you so much, Siddharth. Thank you so much for the interactive session. Well, let's just take a 15-minute break. Now we have some chai and coffee around, and then some biscuits that Abbas got pretty fresh from Nilofer Cafe. Right? That's the Hyderabadi style of having a small break in between, right? Let's just do that.